asked you to do. Okay, so hopefully we're recording. I've got a weird message on the screen, but I don't know why. All right, so we've got the printout of section 1.6 right here. It is now in your Canvas section, so if you want another one, you can go and download it and print it. And so now we are going to work through these problems. So there's 3 pages of problems. We're going to do most, if not all, of the problems. So here we go. Example 1 says this. So read along with me. I'm not going to write the whole problem up here. Example 1 says the painting of, it should be the painting on, I'm not a great typist, so sorry. It should be the painting on the world's, it would be, that's not really a great thing to paint, would be the world's largest easel. Who would care? But that's okay. The painting on the world's largest easel has a perimeter of 112 feet. Its length is 8 feet more than its width. What is its length in feet? Okay, so we've only talked about linear equations. Our whole goal here is to set up a linear equation of some sort. So I'm just going to draw real quick a rectangle because pictures sometimes help me think. So here's the painting that's on the world's largest easel. We are told that the perimeter is 112 feet. Perimeter is something you're going to see a few times because it's a fairly simple relationship. What does the perimeter mean you are doing with your rectangle? You're adding up the sides. Great. That's why we're talking about this. So in case you didn't know, the perimeter, I'm going to symbolize with P, just means to add up the sides. We are given a relationship between the sides as part of the problem. It says the length is 8 more than the width. Okay, so the length is 8 more than the width. So that tells me that once I know the width, the length is going to be 8 feet more. So help me out as I've got my picture and I want to make sure I know what my variables represent. If I define a variable x, what is x going to be? What don't we know? Okay, we don't know the width, we don't know the length, but we do know a relationship. Once we find what, we can then find the other. What's the first one that we don't know anything about? The width. But we're told once we do find the width, I can find the length. Would everybody agree with that? Okay, so since I don't know anything about the width, I'm not told anything, I'm going to call the width x. And now the problem told me that once I find the width, what is the length going to be? X plus 8. Fantastic. That's, in any word problem, that's the hardest part, is setting it up and figuring out what the variables mean and what the relationship is. This next part is probably going to be much simpler. Okay, so the perimeter is what I get when I add up all the sides. So the problem tells me, what is the perimeter? And then let's add up all the sides. How many sides does a rectangle have? 4, even though I've just labeled 2. Don't forget to go around the whole thing. So the left side is x. What's the top? What's the right? And then the bottom. And there's your equation. From here on out, there's nothing different than we've done a dozen times already. So I'm going to add up my like terms, x and x and x and x, 4 of them. 8 and 8 is 16. I'm going to subtract the 16 from both sides, and I believe that gives me 96, but you should always double check my arithmetic. It's suspect. And then I'm left with 4x, and then when I divide by 4, I get that the result here is 24. Now that's good and lovely, but since we have been asked a word problem, we want to give our results in words. So we're just going to answer the question. So I look back and the question says, what's the length? Okay, great. I don't even have to give the width. I just got to give the length. So what does 24 represent? 24 represents the width. So 24 is not the answer that we are going to give, but I need 24 to get the answer. Because once I have the width, what's the length? 32. And so I'm just going to come over here and say the length is 32 feet. Don't forget your units for word problems. If there are units, which there were in this case, then you want to give the units. All right, what I would like you to do while I figure out if we're actually recording here or not is look at example 2. This, in example 2, instead of being about a rectangle, it's about a triangle, but you're given relationships, so give it your best shot. I'm going to give you about another minute or so. I hope the hardest part to this is defining what the lengths of the 3 sides are. So if you did that, you did great. If you're struggling with that, well, we'll figure it out. That's why we're here. All right, so the problem says this. Keep working if you're still working. I'm just going to get started. Check your work with my work. Ask the questions that you need to ask, okay, so that you leave here feeling better than when you came in. So example 2 says the perimeter of a triangle. So again, perimeter. Again, we're going to add up all the sides. So that is absolutely no different no matter what figure you're dealing with. So the perimeter of a triangular plot of land is 2,400 feet. Now we get some relationships. The longest side is 200 feet less than twice the shortest. So there's a relationship between the longest and shortest. Which one do I not know anything about between the longest and the shortest? The shortest. So that's my clue that that's going to be my x. Because once I know it, I am given a way to find the longest side. Okay, does that make some semblance of sense? I know word problems are tough. I totally get it, and I empathize. I'm just trying to make them a little less painful. Okay, so we're given a relationship between the longest and shortest. We're not told anything about the shortest, so we're going to call that one x. Continuing on, the middle side is 200 feet less than the longest. Okay, well, once I know what the longest is, I know how to find the middle. So we can find all 3 lengths. So here goes. the second sentence tells us the longest side is 200 feet less than twice the shortest. So here's my short side. I'm going to call that X because I don't know anything about it. But once I know that one, what do I do to X to get my longest side? Okay, we multiply it by 2x, and then you subtract 200. If you wrote 200 minus 2x, okay, the word less in that sentence, it says the longest side is 200 feet less than. That means you start with the 2x and you subtract the 200. That's 200 less than 2x. This is 2x less than 200. Okay, so there's an implied order with subtraction. You've got to be a little bit careful. Okay, fantastic. Now, once we know the long side, it says the middle side, or the medium side as I've labeled it on the board, the middle side is 200 feet less than the long side. Okay, so what I'm going to do is I'm going to take the long side, and what am I going to do to the long side? Yeah, I'm going to subtract another 200. That is 200 feet less than the longest side. Okay, so again, that less than relationship implies the order. That's tough. Okay, so if you didn't quite get that, don't beat yourself up. Just learn what you can, and that's why you have a few homework problems that you're going to look at. It's going to be the same sort of thing. Everything in the homework is an addition relationship. Okay, so now the perimeter, we are told, is equal to 2,400 feet. So the perimeter means to add up the sides. So I've got X plus this one plus the long side, and that's equal to 2,400. At this point, now that you've got the equation, you've done the very hard part to the word problem. At this point, it should be like a cool down lap, solving the equation. We're going to make this look neater. We're going to clean it up, and then we're going to solve. So first thing I'm going to do is I'm going to collect those like terms. I've got X and 2X, that's 3. Plus 2 more, that is 5x. Negative 200 and negative 200, that's negative 400. And another negative 200, negative 6. I'm going to add the 600 to both sides. Divide both sides by 5. And I get, let's see, that's going to go 4. 50,000. I'm sorry? Exactly. Just making sure you guys are awake. Good, good. You're doing great. No, that's just me. Sorry, scatterbrained. I added the 600. I got 3,000, but then I wrote down 2,400 just because. Why not? So now I fixed it as I was instructed because I'm a good listener. So when I add 600 to 2,400, I get 3,000. And now I'll divide by 5, and that's a little easier, 600. This time we are asked the lengths of all the sides. Okay, that was the question we were asked to answer. So here goes. I'm just going to label my picture, or you can write out a quick sentence. The short side is this. The middle side is this. Here we go. X is 600 feet. Always use your units. The long side, 2 times 600 is 1,200. Minus 200 is 1,000 feet. And then 2 times 600 is 1,200. Minus 200 is 1,000. Minus 200 more is 800. You can always check. Do those 3 values add up to 2,400? Indeed, they do. And so I feel pretty good about that. Okay, so those are the 2 word problems on the first page. Every word problem you see as you go through your homework is going to be based on addition. Now we're turning the page. Example 3. I've got one, you've got one. This is probably the most important type of problem. There's one of these on the final exam a long time from now. Okay, so want to make sure that you've seen several of them. I'll probably put one on the test on Wednesday. Don't tell. Okay, so here we go. Example 3, mixture problems. So example 3 says this. We are a chemist in our lab, and I want to know how much pure alcohol should be added to 20 liters of 40% alcohol to increase the concentration to 50%. Now, Whenever I do a mixture problem, if you had intermediate algebra, we cover them there, but in a slightly different context. I'm going to kind of show you the same sort of process. So what I'm going to do is I've got two beakers. Okay, this is my first beaker, and then this is my second beaker. And I'm going to combine the contents of those two beakers into a third. And I'm told the characteristics of each of them. So this problem says that it says how much pure alcohol should be added to 20 liters of 40% to increase the concentration. So that means I am starting with my 40% solution. I've got a 40% solution, 20 liters of that, and I want to increase the concentration. So over here, this is my beaker. What's the percentage of alcohol that's in this liquid right here? So here's my liquid. What's the percent alcohol it is? Okay, it's 40%. Just because I know percents are also another thing we struggle with. Remember, 40% means that not everything in the beaker is alcohol molecules. Okay, so that means that the other 60% in the case of alcohol or some of the problems in the homework are acid because you're a mad chemist. Okay, the rest of it is water. So 40% of the liquid in here is alcohol molecules. The other 60% is water molecules. So how much do I have in this beaker? What's the total volume? 20 liters. I'm going to use a capital L for liters. I want to increase the concentration. For whatever purpose, I need a 50% concentration, and all I had on the shelf was 40%. But I do have some pure alcohol. So what is the concentration? What's the percentage of alcohol molecules in pure alcohol? Perfect. Great job, everybody. That is a tough thing. It is 100%. By the way, this little diagram that I'm going to use in the last line for the equation we're going to set up works no matter what. So if the problem you're doing says you have an 80% solution, then you're just going to put 80% here. Okay? So it doesn't matter. Okay, so 100%. How much alcohol am I adding according to the problem? Why don't we know? What are the words that indicate to me that I don't know how much pure alcohol I'm adding? How much? Underline the words how much if you didn't see that. Okay, X. How much pure alcohol? How much 100% am I adding to my 20 liters of 40%? So I don't know that. But I do know what I want to get. So what percent concentration do I want to have at the end? Okay, I want to raise the concentration of alcohol molecules from 40% of the volume to 50%. I want half the molecules to be alcohol instead of 40% of them. Now, here's the first key question for you. If I start off with 20 liters of something and I add an unknown amount to my beaker, what's the volume that I have as a result? What was that? 20 plus the amount I don't know. So 20 plus X. This is how much I started with. This is how much I'm adding to it. These are hard problems. Okay, you're never going to hear me say that they're not. Okay, so if you have a question or anything that I did not do an adequate job explaining, please let me know. The final thing is we have to remember how percents work. Okay, so let's just say you won $1 million from the lottery, but then the government takes 40%. Boo. Yes, boo. I want it all. How much money, how do we calculate, maybe you can't do that in your head, how do we calculate how much money we are paying to the government from that $1 million? What do? Multiply by what? 0.40. Sorry, everybody's got math. I can't see who's talking. Yes. You never multiply by the percent. Remember, we always have to move the decimal 2 places to the left. So if you want to know how much of the $1 million you've got to give away in taxes, you multiply by 0.40, it's going to be $400,000. Okay, that's how you figure that out. So this is how we are going to figure out our equation. We're going to use the percents. So if 20 liters is the amount of volume I have, and 40% of that is alcohol, what am I going to do to calculate the amount of alcohol molecules in that beaker? Perfect. 20 multiplied by 0.40 or 0.4 if you don't want to put the 0 there. It's not necessary. And you can do the multiplication as we go. That's totally fine. Plus. What's the number that I use for 100% when I move that decimal? 1. 100% means all of it. So you multiply by 1. So how much of this is alcohol molecules? All of it. I'll write the times 1 there just so that you know when you're looking at your notes later what I did. This is 100% of this volume is equal to, well, once again, whatever this volume is, this 20 plus x, that's the total volume. What do I do to figure out the amount of volume of alcohol molecules? Perfect. You multiply the 20 plus x, I'm going to put parentheses around it, by 0.5 or 0.50. So in my estimation, there are 2 very key components that you have to remember to doing the mixture problem. And once you get them settled, once you've done 3 or 4 mixture problems, you're going to be good to go. Because once you've done one, once you've done this one, there's nothing new to any of the others. It's just a matter of you figuring it out. Okay, so the first thing that you have to do is you've got to remember this key bit right here. Don't forget to add your volumes. And then the other key bit is don't forget how percents work. Okay, you got to make it a decimal before you can do the multiplying. And now from here, it's just a normal problem. Okay, we're gonna make this look cleaner, and then we're gonna solve. So 0.4 times 20, that is 8. 1 times x is x. 0.5 times 20 is 10. 0.5 times x is 0.5x. Now, I didn't do this earlier with decimals because we tend to be more comfortable with decimals than fractions, but just in case, we can clear the decimal just like we cleared the fraction. I would recommend it if you have 2 or 3 decimal places. What do I multiply the 0.5 by so that I no longer have a decimal? Right, 1 decimal place. I'm going to move it 10. Okay. So if you want to clear the decimal, I'm just going to show you how on this one. This is not a required step. The problem will work out if you continue to work with the decimals. But if you want to clear the decimal, I'm going to multiply everything by 10. Okay, so I'm just going to put a big parenthesis around it, and I'm going to multiply everything by 10 to move that decimal. Remember, you can't just move the decimal on this term and not do compensating things on the other terms. So here we go. 10 times 8 is 80. 10 times x is 10x. 10 times 10 is 100. And 10 times 5 is 5x. And now I have no more decimals. If that makes you happy, then there you go. Now I'm ready to solve. I'm going to bring the 5x over to the left because I like x's on the left for whatever reason. So when I subtract 5x from 10x, I get 5x. When I subtract 80 from both sides, when I take the 100 and subtract 80, I get 20. And then when I divide by 5, hopefully I do this all right, I get x is 4. So the question that we were asked half hour ago is, how much alcohol do I have to add? Well, how much alcohol was x? So what I need to do is I need to add 4 liters. Units are important. Yes?
So the way you set everything up, will be able to use it for other questions like the same?
Mm-hmm. I hope so. Otherwise, I wouldn't waste your time. Okay. Honestly, I'm not going to show you something that's going to work. Any mixture problem, and in fact, I don't think there's any in our homework, but I could be wrong on that. All my classes get jumbled together. This works whether you're talking about percents or whether you're talking about amount of money. You can put money there if you're talking about if you're selling nuts, and some nuts cost $5 a pound and others cost $8. I don't remember if that's this class or the intermediate algebra class that there's problems like that, but this works no matter what. Okay, and for me, I need a way to put my information out there because otherwise my brain will clump it all together and I'll never be able to do anything. Okay, so if this is good for you, good. The book, if you click the link in my math lab to look at the book uses a little spreadsheet. And that's great too. If you like that, go and look at that method. It's the exact same thing. It's just oriented a little different. So while I erase the board, what I would like you to do is example 4 is another mixture problem that you can use the same thing. So give it a try, please. All right, example 4 says this, that a chemist wishes to strengthen a mixture from 10% to 30%. Again, how much pure alcohol should be added to 7 liters of the 10% mixture? So here are my beakers. What do I start with? What percent is my mixture that I start with? 10%. And how much of that 10% mixture do I start with? 7 liters. Great. And then I'm adding to it what? 100% pure alcohol. Beautiful. Just making sure we're putting the right information in the right place. And how much volume of pure alcohol am I adding? Don't know. That's what I'm looking for. So I'm going to call that X. Then on the other side, I want to end up with a 30% mixture, and I'm going to have 7 plus X liters. So the setup is almost identical to the previous problem. And again, I told you if you're not even working with pure alcohol, if it was 80%, this totally works. Okay, so just you use this to sort things through. So I've got 0.1 times 7 plus 1 times X is equal to 0.37 plus X. So that's 0.7. 0.3 times 7 is 2.1. I'm going to clear the decimals again. You don't have to. Remember, you can work with the decimals. Everything's going to work out all right. I'm going to multiply everything by 10. 10 times 0.7 is 7. 10 times X is 10X. 10 times 2.1 is 21. And 10 times 0.3 is 3X. Now I'm ready to rumble. I'm going to subtract the 3X from both sides. So 10X minus 3X is 7X. I'm going to subtract the 7 from both sides, and I get 14. And when I divide both sides by 7, I get that the X value, which I can't seem to draw an X here for some reason, is 2. So how much pure alcohol? We need to add 2 liters of pure alcohol. All right, we're just about done. You're doing a great job. I'm going to read through example 5, and I'm going to give you about 20 seconds to think of the first part, what you might write down for it. So example 5 says this. A technician runs a copying service in his home. Good for him or her. He paid $3,500 for the copier and a lifetime service contract. Each sheet of paper costs $0.01, or that's another way of writing 1 cent. And he gets paid 5 cents per copy. That's all the information. Let X be the number of copies. So what I would like you to do first is A, express cost as a function of X, meaning write an expression for how much it costs this person to make X number of copies. I'm going to give you 20 seconds to think about that, maybe 30. Again, I know these things are difficult. I'm just trying to give you a little experience. There are 2 components to this person's cost. What's the first component to the cost? I'm sorry, the maths are making our, what'd you say? The paper, great. So here we go. So how much does the paper cost this person when he's making copies? Okay, 0.1, or sorry, not 0.1, 0.01x. That's 1 cent for each piece of paper he uses. There's a second component to the cost. What's the other component to the cost? 3,500. Does that matter how many copies this person makes? No, that is a fixed cost. So 3,500. So this is a super, if any of you are business majors or economics or anything like that, this is a super simple example of a cost function. Okay, so this has some real world tendency, but you know, the real world's a little more complicated. Okay, the B part, I'm going to give you 20 seconds. Now that you've seen this, maybe the B part will be a little easier. What's the revenue? Meaning how much money does this person take in for all the copies? So what does this person take in for each copy? 5 cents. So the expression for the revenue is 0.05x. Have to have the x, otherwise they're just making 5 cents. That's not much fun. You with me? All right, the last one is, what's the break-even point? What do you think we do with the cost and the revenue to figure out what it takes to break even? Equals. Yes, when the revenue, meaning the money you take in, equals the cost, meaning the money you pay out, that's called the break-even point. Don't know if you realize that. That's why I just wanted to make sure. So the last thing here is the break-even point is where the cost equals the revenue. So the cost is 0.01x plus 3,500. The revenue is 0.05x. And I'm going to leave the solving part of that to you. Okay, that's not a super hard equation to solve, but the word problem, was a little difficult to set up. We've got 2 problems left, 1 problem for each of us. We've got just enough time. So the last problem I'm going to do for the day and the week is example 6. We are going to solve this. There's a typo on the sheet. It should be solved for, oh no, there's not a typo on the sheet. I know what I'm doing sometimes. We're going to solve for lowercase a. And here is the equation. Capital A is equal to 1/2 h times a plus b. In formulas, the case matters. Okay, so when we're solving for little a, it's already solved for capital A, but those are different things. So this is just solving using our tools that we know how to use for solving, but we're using it when there's more letters than we've seen before. So on this problem, what's the first thing that I should probably deal with to make it a little bit easier? The fraction. What am I going to multiply each term here? And there's just 2 terms. There's 1 term on each side. What am I going to multiply each term by to get rid of the fraction? 2. That's the only denominator, so then it's the common denominator. I'm going to multiply each side by 2. So on the left side of this, I've got 2 times capital A. On the right side, the 2's cancel, and I have h times a plus b. Great. We're 1 step closer. There's 2 steps to go. Actually, you have a choice, but I'm going to recommend a particular way. So if I want to get the a alone, I have to first get the a plus b, the parentheses alone. So what should I do to both sides next, would you think? Yeah, this is h times that. So the reverse of multiplying by h is dividing. So I'm going to divide both sides by h. So that means on the left, I have 2 times capital A over h. On the right, the h is canceled, and I have a plus b. I'm just going to call a timeout. Somebody here might be thinking, hey, Perkins, could I distribute the h here? Yes. Okay. You could distribute the h, and then move this term over, and then divide, and do the dividing last. Your answer is going to look a little different, but it's going to mean the same thing. Okay, so that is totally fine. Last thing, if I'm solving for the lowercase a, what is the last thing I have to do? Subtract the b from both sides. Yes. And since I'm subtracting the b from the whole fraction, I've got 2 times capital A over h. Let me write this up at the top so everybody can see. And so I'm actually being a good instructor. So when I subtract the b from both sides, on the left side, I have 2 capital A over h, then minus b. Okay, we subtract b from the whole thing that was there, not from just the numerator. And then on the right side, the b's cancel, and I'm left with a. And there we go. I've just used the same techniques for solving that we already have, just there. So we've got 2 minutes left, just enough time. Do example 7. It's actually a little bit simpler of a problem. All right, so we're asked to solve this for L. So here's my L right over here. What's the first thing that I need to move in order to get closer to the L being by itself? Yeah, this 2W does nothing for me, so I'm going to move it first. And so since this is a positive 2W, how am I going to get it over there? Just subtract it. So what I have on the left now is P minus 2W. On the right, I have 2L. One more thing to do. What is that? And we're dividing the whole thing by 2, so I have P minus 2W over 2 is equal to L. One thing before you go, do not make one of the cardinal sins. I cannot just cancel the 2's here, because if you're going to distribute the 2, it has to be in both terms. Okay, so just leave it like that, and you're done. I hope you have an amazing weekend. Those of you who had some Canvas things to talk about, hang around.